Welcome to the April 22nd virtual day assignment. It's a little annoying we're having to do this, but I try to make sure it's something we've just been doing. So we'll end up doing the lab that we are going to do on Friday, early next week. If you scroll down here to the unit we're in, which is ranking, energy and energy conservation, these are ranking work energy bar chart explanations. So that's a video I made yesterday. I'll also put up here in just a few minutes the solutions to the work energy bar charts that you turned in class today. The energy ranking tasks are two concept builders that I'm going to ask that you do on the physics classroom. So there's your link to the physics classroom. Please read. This is how I'll score the points. It doesn't always show up like that on physics classroom because it's a little snarky for me how to get the points. But read this carefully. That'll be how I end up scoring it. Okay, this is due at the end of the day tomorrow. Well, I'm making that on April 21st, but the end of the virtual day. Both of those should take you less than what time you would have as your class time. And we'll have a synchronous session to go over these as well. So at that point, if you go to this page, and you click on it, you're going to come to the physics classroom. You're going to need to click into where it says your account. Now, for me, I am already in that account, so it'll look different for you, but you'll have a couple assignments. The concept builders, you don't have to click over here. You just go to, you look at your assignments. It'll describe the two that you have, which are also the same two that are described here. Energy ranking tasks and match that bar chart. And those are going to say that they're due tomorrow. So you won't have to go through the steps I'm going through now. It'll take you directly there. So the first one is the energy ranking tasks. And again, when you get to this, there's several different levels. There are different points for different levels. You choose which ones you do, but note which ones have more points than others. So there's rank that PE, rank that KE, and rank that speed. So if you have something like this, you have this situation, you read this up here, it's asking you to rank the potential energy. Well, you should know that potential energy is MGH, so the higher it is, the more it will have. Now, these two are really close, but A is a little higher than C. So I'm going to say that's the greatest. C is the middlest, and I would say B is the least because it's the lowest. I'm going to check my answer. Oh, drats, I got that wrong. That's okay. So it'll take you back. If you do get things that are wrong, you could go to help me about that particular question or about how to think about the situation. You also can go to view the directions again. So kind of made a mistake there on purpose. I wish it would take me back to that direct one, but I'll go and show that again. So this one says a disk slides along a low friction surface along the path that's shown. Rank the gravitational potential energy at the three marked locations. So the highest, you're going to have the greatest potential energy. That's C, so most potential energy there. This is the middlest. This is the middle height. This is the lowest height, so it would have the smallest. And when I check that answer, that one's the data way. And this goes through a bunch of ones similar to this. I'm going to go back to the main menu. So this one will do something similar with kinetic energy. This one will do something similar with speed. So if I look at this is released. It's on a pendulum, ranking the speed of the ball. So the speed depends on the kinetic energy. So you should recognize that where the gravitational potential energy is the most, kinetic energy would be the least. Where gravitational energy would be the least, kinetic would be the most. So this would be moving the fastest, and therefore it would have the fastest speed. That's C. This would be moving the slowest, so that has the slowest speed. And this is the middlest. And I'm going to check that answer. Very nice. So now I'm going to go back to the main menu, and I am not going to finish this because this is just a tutorial for you. So once you finish whatever levels of that one you want, you go back to, again, your account. You're going to look for the one, again, you won't need to go through these menus, but you're going to look up the one that basically says match that bar chart. Not the lull charts, match that bar chart. Again, there's three different levels here as well. There's the apprentice level, there's the master level, and there's the wizard level. Both the master level and the apprentice level I think are fairly straightforward because they don't have friction. So I'll do one example here. And then the wizard level is more challenging. There is friction, which causes dissipated energy as heat. So I'm going to take a look at this. So the key thing here, there's only 6 choices for each of these. You just need to have ones that are consistent. As we saw in class on Thursday, it doesn't matter necessarily what the exact bars are, but that your answers are consistent with each other, and these will all be consistent with each other also. So up here it says I've got 4 bars of potential energy, 1 of kinetic. So I'm going to look at B. This would have less potential and more kinetic. This would have less potential still and more kinetic, and this would have the most kinetic and the least potential. Now, when I think about this, because energy is conserved, I should have 5 total bars in all these situations. So if I look at B, I know it's going to have the most potential. Well, that doesn't even have 5 total bars. That doesn't 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 have 5 total bars. That does. Wow, that was easy. I didn't even think about that they would all be like that. So this has 3 potential and 2 kinetic. Here at A, it should have more kinetic and less potential. So this has the same amount, and it doesn't even have 5 total bars. So this has 5 total bars, but I wouldn't be all kinetic energy here because it's still above this lowest spot. So I think it's going to be this one, 3 kinetic and 2 potential. For C, it's the lowest spot, so it should have the most kinetic. Either 5 kinetic and 0 potential would be fine, or 4 kinetic and 1 potential. But the only one of those options I see is this one, so I'm going to check my answer. And data away. So now I'm going to go back to the main menu, but once again, there's a help menu, and there's view directions. So I'm going to try a wizard level question to show you what that looks like. So these bar charts look a little different. Notice it says, consider the effects of friction, air resistance, and collisions. So kinetic energy, gravitational potential, dissipated energy, and elastic potential energy. So in this case, we've got looks like a skier or a sledder going over a series of hills before finally stopping at C. So if it says stopping at C, you know there's going to be no kinetic energy here. So we'll think about A and B and C. So here there is some dissipated energy, that makes sense. There's some potential energy, that makes sense. And there's some kinetic energy. I would think there'd be more kinetic energy than this. Maybe not, depending on how much is dissipated, but I'm going to check these options out. So that doesn't make sense because that has more potential energy than it did at the top. That doesn't make sense because there's no kinetic energy there. That doesn't make sense because there's no dissipated energy and it has more kinetic energy than at the top. So this one has this has more potential energy at the top, even though otherwise it would be okay. I don't think that's right. Actually has the same as at the top, but has less kinetic, and that doesn't make sense. And then this has half kinetic, half dissipated, but we know it still has some gravitational potential. So I'm going to go back to this first one. I think that's correct. So apparently it's not speeding up, but it is losing potential energy and gaining dissipated or heat energy. So part B, I definitely should have more orange, less green. I'm not sure about the red. So that has more orange, but has more green. That has more orange, less green, a little less red. So that's a possibility. That's not a possibility. That seems not a possibility because it should still be moving. That seems not a possibility because I don't gain potential energy. And that one, again, doesn't seem like a possibility because it still has some potential energy. So I'm going to go back to this one. So that makes sense. At the end here, it said it stopped. It had no potential energy, so I'm thinking there should be one that's all orange. So I think that's going to be it. If you have questions about which things are, you click that question mark. If you want to help me or view directions, you can do that also. So I'm going to check those directions and data away. So that level is definitely more challenging, but it also shows your understanding quite a bit better. All right, so that's all I've got for these. Hopefully this helps, and hopefully you can also come to the synchronous session tomorrow.